Dear students, now we will discuss about important questions or simple questions which are given in a previous question papers, and we will learn or we will know easy to hard. So first of all, we see which questions are simple and easy, or we can say which is on a formula based question. So let us see, and first we will learn and we will know, then we will go one by one. So these are useful for our examination. So in the fourth sem, the question paper comes very easy. Why? Because the question patterns are question styles, or what we say, particular questions will definitely comes in the question paper. So one by one we will discuss here. Already we discussed syllabus. Now it is like a revision or a recall, or observing the model papers, model questions. See, this is a question, the heading is given solve. So this type of questions, this is called differential equations. So this type of questions, 4 to 5 questions minimum comes in the examination. So if you know this method how to do, then we will get easily some marks. Look here, the question is given: solve d square minus 5d plus 4 of y equals to 0. So the given question is already in a symbolic form, so we have to write it in a auxiliary equation, that is, we simply say AE. So in place of d we have to write m. So m square minus 5m plus 4 equals to 0. Here we need not to write y. Think that y, if it goes to right side, it becomes 0. So now we have to find the roots for m. So if you know the factorization, then according to the factorization we can find the roots. That is, minus 5m we can write minus 4m minus m. So before doing that, first think first and last, that is 4 and m square we have to multiply. So 4m square, to the 4, the factors are 4 into 1, or 4 and 1. So minus 4 minus 1, if we multiply we get plus 4. So minus 4m minus m, if we add we get minus 5m, that is the middle of the term. So we can write it as a m square minus 4m minus m plus 4 equals to 0, to bring the factors or roots. So from first two terms we can take m common, then m minus 4, and in the last two terms we can take minus 1 as a common, then we have minus 1 of m minus 4. So in both places we have m minus 4, so again take common m minus 4, then we have m minus 1 equals to 0. So m minus 4 equal to 0, or m minus 1 equals to 0. That means m equal to 4 or m equal to 1. So here we have different roots. So the solution is y equals to c1 into e power m1 x plus c2 into e power m2 x. So in place of m1 you can write any of the root. So 4 and m2 write 1. So y equals to c1 into e power 4x plus c2 into e power x. Next question, look here. If we don't know how to find the roots or factorization, then another method is also there. That is, you can see here. See the question first. Solve m square d square plus 2d plus 1 of y equals to 0. So in the solution, write it, and next step, auxiliary equation. M square plus 2m plus 1 equals to 0. Here we need not to write y. To bring m roots, if we don't know the factorization, then we can do by using this formula, that is m equals to minus b plus or minus under root b square minus 4ac by 2a. So from the equation we have to know the a, b, c values. M square coefficient is a. There is no coefficient means we have to take 1, and m coefficient is 2, that is we say b, and constant is c. So after substitution we get the m roots. Here roots are same, so sometimes roots came different, sometimes same. So here roots are came same. So the formula little bit changed. So finally the solution is y equals to c1 plus c2x into e power mx. So in place of m we have to put minus 1. That's enough. So this type of questions comes for 1 mark or 3 marks or 5 marks, but must come. So don't neglect. Next, we can find the roots by using calculator also. So if you know, you can check or you can find through calculator. Next, so another question we will see here, the right side something is given, instead of 0 some extra given. First of all, solve means we have to do the CF and PI. So equal to 0 is given in a question to the right side, then we need not to find a PI. But when instead of 0 e power x or sin x, like these terms given, then we have to find PI also. So first consider it is as a equal to 0 for CF. In the same way, if you don't know the PI, at least find CF, then go for PI. See here, the question is taken and it converted in auxiliary equation, and then find the roots. Here roots are different, so here we are not concluding with solution, we are saying CF, because right side we have terms. So here half of the part is over, that's why we are saying it is complementary function equals to c1 into e power minus 1x plus c2 into e power minus 2x. And for right side terms we have to find PI also. So for pi I will tell you in the, so here pi is means we have to write down the left side part to the right side, and it comes under the right side part because left side it is multiplying. So pi equal to, we can write e power minus x plus e power minus 2x by d square plus 3d plus 2, and in place of d we have to substitute minus 1. So that is pi, I will tell you later. But for this here we have up to half of the solution, that is up to complementary function, and I will tell you how to find this pi also. Here in the single page we have here up to the 50% solution. So this means whatever the question may be, we can easily do up to 50%. The right side, either it is x or sin x or cos x. So please at least do 50%, and some questions we will discuss now. See, this is related to Laplace transformations. So few formulas and one or two problems here we will discuss. Laplace transformation of e power at equals to 1 by s minus a, and Laplace transformation of sin at equals to a by s square plus a square. Laplace transformation of cos at equals to s by s square plus a square. Laplace transformation of sin hat equals to a by s square minus a square. Laplace transformation of cos hat equals to s by s square minus a square. So here in this page 5 formulas given and 2 problems are there. So first read the formulas and write each formula 10 times. Then look at the problem. Question is, find the Laplace transform of e power 3t minus e power minus 3t. So in the solution, take Laplace transformation of given function or question, that is e power 3t minus e power minus 3t, and here we have two terms, so for each term we can split the Laplace transformation. So Laplace transformation of e power 3t minus Laplace transformation of e power minus 3t. So 1 by s minus 3 minus 1 by s minus of minus 3, that is s plus 3. And third bit or another question. T cube plus 5 into cos t. So take Laplace transformation to given question, and for each term we can separate or we can apply the Laplace transformation, that is Laplace transformation of t power 3 plus Laplace transformation of 5 into cos t, that equals to 3 factorial by s power 3 plus 1 plus 5 into 5 is a common because taken common because it is a constant, and it is multiplying with cos t. So we can write it outside, and Laplace transformation of cos t. 3 factorial means 3 into 2 into 1. So that is 6 by s power 4 plus 5 into Laplace transformation of cos at means s by s square plus a square. Here a means 1. So s by s square plus 1. So this is the solution or answer or Laplace transformation of the given function. So these are simple questions. If you know 2-3 formulas or few formulas, you can easily write the answers or solutions. Let us see next question. See here, Laplace transformation of f of t equals to, we can say simply f bar of s, and the definition is integral 0 to infinity e power minus st f of t dt. So now we see Laplace transformations formulas. Here 4 given. Laplace transformation of 1 equals to 1 by s. Laplace transformation of t equals to 1 by s square. Laplace transformation of t square equals to 2 factorial by s power 3. Laplace transformation of t power so Laplace transformation of t power n equals to, we can write n factorial by s power n plus 1. And see the question. Find the Laplace transformation of 8 into t power 3. So here 8 is a product with t power 3. So 8 is multiplying with t cube. So we can write it outside of the Laplace transformation because it is a constant. So now Laplace transformation of t power 3 means 3 factorial by s power 3 plus 1. 3 factorial means 3 into 2 into 1. That is 6 by s power 4. So 6 into 8, 48. So here t power 3 is we can say 3 factorial by s power 3 plus 1. So finally we got 48 by s power 4. Next we will do, or we will see another problem. So just a second. Next some more questions we will discuss now. Next, this model, see here. Find inverse Laplace transformation of 1 by s minus 3 plus 1 s by s square plus 4. So here we have two terms. So for each term we can give, or we can write inverse Laplace transformation. That is inverse Laplace transformation of 1 by s minus 3 plus inverse Laplace transformation of s by s square plus 4. So we can write inverse Laplace transformation of 1 by s minus a is e power at. This is a formula. So that's why it is kept in bracket. And the second term also we can say it is in the formula of inverse Laplace transformation of s by s square plus 2a square, that equals to cos 80. So here in the first term a means 3, so e power 3t, and here second term a means 2, so cos 2t. So here we have to conclude right as a e power 3t plus cos 2t, that is the solution. So here only formulas given, so based on formula we can write the solution, and here the solution not written, so you have to write one line, that is e power 3t plus cos 2t. Next question you can see here, find inverse Laplace transformation of 1 by 2s plus 5. So if we take 2 from the denominator of the two words, we can write 2 of s plus 5 by 2. So here 5 by 2 consider as a. So 1 by s plus a means e power minus at. So inverse Laplace transformation of 1 by s plus a equals to e power minus at. Here a means 5 by 2, so e power minus 5 by 2 t. So the 1 by 2 as it is we have to write outside. Next question, find the Laplace transform of t power 4 plus e power 2t. So t power 4 means t power n. N means 4, so 4 factorial by s power 4 plus 1, and e power 2t means e power at. So 1 by s minus a. These are all formula based questions. So at beginning we are studied or we saw the formulas, now we are applied here. So next another question or another formulas we discuss. Next question is, look here, find Laplace transformation of e power 2t plus 4t cube minus 2 into sine 3t. For each term we can separate or we can apply Laplace transformation. So Laplace transformation of e power 2t plus Laplace transformation of 4 into t cube plus Laplace transformation of 2 into sine 3t. So that equal to, we can write 1 by s minus 2 plus 4 into t cube means 3 factorial by s power 3 plus 1 plus 2 into sine 3t means a by s square plus a square, that is 3 by s square plus 3 square. So whatever we used here we are kept in the formulas in a bracket. So that is Laplace transformation of e power at equal to 1 by s minus a. Laplace transformation of t power n equals to n factorial by s power n plus 1. And Laplace transformation of sine at equals to a by s square plus a square. So like here we applied and simplified. So remember that Laplace transformations and inverse Laplace transformations, there is a difference. after the Laplace transformations we get in s terms. In inverse Laplace transformations we get in t terms. So read perfectly. Next, here we are observing, find the particular integral of d square plus 16 of y equals to sine 3x. Here not asking solve, asking a half of the solution, that is second half, that is particular integral. So look here, pi equal to, right side we have sine 3x, so sine 3x by left side we have d square plus 16, so it is now comes under the right side part, that is pi equal to sine 3x by d square plus 16. If sin ax or cos ax, the formula is, in place of d square we have to write minus a square. The minus is outside, and a squares, the square is only for a, not for minus. So very important, because we think minus 3 whole square. No, minus is separate and 3 square is separate. Only a square, only the particularly a has a square. So in place of a we have 3, so the square comes only 3, not for minus. That's why 3 square means 9, and minus as it is written. So minus 9 plus 16. 16 minus 9 we say 7. So this is the particular integral. And one more thing, when we are substituting or after simplification, we should not get 0 in the denominator. If we are getting 0, that means we have to apply the formula. For zeros we have another procedure or another formula. So here 0 is not came, so this simple process here we can apply or we can do. Next question. See, in previous question we discussed for sin ax. Now we are discussing for e power ax. Find the particular integral of d square plus 4d plus 6 of y equals to e power 2x. So pi of so and so, and next pi equal to e power 2x by d square plus 4d plus 6. For e power ax we have to write a in place of d. Here we have 2, so write 2 in place of d. Then we get e power 2x by 18. So here also same condition. If denominator is not 0, we can substitute and simplify. If it is 0, we have to do in another way or another procedure, or we have to use another formula or another method. So for e power ax we have to substitute a in place of d, but whenever sin ax or cos ax is there, we have to substitute in place of d square, not d. So please remember, in place of d we have to write a for e power ax, but comes to the sin ax or cos ax, we have to substitute minus a square in place of d square, not d. So next question, d square y by dx square plus 6 into dy by dx plus 9y equal to 0. So here the question heading is solve. So you already know how to solve. Write it in auxiliary equation, then find the roots. According to the roots, write the solution. Next question. Here, right side given a e power x. So here the heading is solve, means we have to find 2, that is complementary function, and pi, particular integral. So let us find. First write the question and then write the AE. Then according to the roots, here we have roots alpha plus or minus I beta. That means CF is e power alpha x into C1 cos beta x plus C2 sin beta x. So this is a complex numbers, so the solution little bit changed. Next pi. In the pi, the right side we have sine and e power. So for both we have to find pi, and the procedure for both is different. Each one is different style. So split the denominator for each term, and next sin ax means here we are getting 0 if we substitute minus 2 square. So we have to know another method or formula, that is sin ax by d square plus a square. We can write minus x by 2a cos ax. So minus x by 2a cos 2x plus e power x by 1 square plus 4, that is 1 plus 4, that is 5. So minus x by 4 cos 2x plus e power x by 5. So look here, the formula is sin ax by d square plus a square means minus x by 2a cos ax. Whenever the denominator becomes 0, at that time we have to use this formula, otherwise no need. So minus x by 2a cos 2x. Next, so finally we got solution. So CF plus PI. These pages already I posted in our group, so you can see and recall or read. Next, Fourier series. This is important, and on Fourier series 3 to 4 questions comes. At least you write formulas and substitute. For this much you will get 50% marks. So the question asks for 5 marks. If you write at least formulas, that is Fourier series and what is A0 and AN and BN, for these formulas if you wrote, you will get 2 to 3 marks. So after writing formula, you know how to substitute. So easily you will get 3 marks, that is 50%. So Fourier series means, see here, f of x equals to a naught by 2 plus sigma n equal to 1 to infinity a n cos nx plus sigma n equal to 1 to infinity b n sin nx. So find a naught for f of x equals to e power ax in 0 to 2 pi. So a naught means we have one formula, that is 1 by pi integral 0 to 2 pi f of x dx, 1 by pi integral 0 to 2 pi e power ax dx. So e power ax integration is e power ax by a, and e power ax by a, and the limits are 0 to 2 pi. For the integration we have limits. So first substitute the upper limit in place of x and write minus and substitute the lower limit. So after substitution we get e power 2a pi by a minus 1 by a. So remember the Fourier series and a naught, a n, b n called Euler's formulas. So Euler's formulas means you have to write a naught, a n, b n formulas. Next question, see here. Inverse Laplace transformation of s cube plus 2s plus 2 by s power 5. So split the denominator for each term which have in the numerator, and then we have inverse Laplace transformation of s power 3 by s power 5 means 1 by s square, and 1 by s power 4 and 1 by s power 5. Next, inverse Laplace transformation of 1 by s power n means t power n minus 1 by n minus 1 factorial. So based on that we can do each terms inverse Laplace, that is t power 2 minus 1 by 2 minus 1 factorial plus 2 into t power 4 minus 1 by 4 minus 1 factorial plus 2 into t power 5 minus 1 by 5 minus 1 factorial. Next we simplify, we have t plus 2t by 6 plus 2t power 3 by 6 plus 2 into t power 4 by 24. So here in the last term we have to write t power 3. Here the printing is not came, or unfortunately not written. So imagine this is a simple problem. Just separate the denominator and apply the formula, only one formula for 3 terms, that is 1 by s power n. Inverse Laplace transformation of 1 by s power n equals to t power n minus 1 by n minus 1 factorial. Next, write the Fourier series for a function f of x in c to c plus 2 pi. So f of x equals to a naught by 2 plus sigma n equal to 1 to infinity a n cos nx plus sigma n equal to 1 to infinity b n sin nx. So there is a chance to ask Fourier series formula. See next question. Fourier series we know, and Euler formulas means a naught, a n, b n. A naught equal to 1 by pi integral c to c plus 2 pi f of x dx. An equals to 1 by pi integral c to c plus 2 pi f of x cos nx dx, and bn equals to 1 by pi integral c to c plus 2 pi f of x sin nx dx. Exercise 3.1. Find the value of a naught in f of x equals to x plus x square in minus pi to pi by Fourier series. A naught equals to 1 by pi integral minus pi to pi x plus x square dx. So here we have to separate the integration, and the integral of x is x square by 2, and the integral of x square is x cube by 3, and then upper limit minus lower limit, and you will get the a naught value. Now next question. Find Laplace transformation of cos 2t plus sin ht plus 1. So we have three terms, so separate each term, then we get Laplace transformation of cos 2t means it is in the form of cos at, that is s by s square plus a square, and sin hat means a by s square minus a square, and Laplace transformation of 1 means 1 by s. So substitute in the formulas. In place of a, first write 2, and for second term write 1, third time it is 1 by s. So by using formulas, simple formulas, we can do the problems. So I hope you read formulas and you know how to apply the formulas, and then if you know the substitution and simplification, then you will get full marks. So try, and all the best. Have a nice